The Mars Underground City. These are the digging robots that are drilling, blasting, and removing regolith, the Martian soil and rock, making space for the new city on Mars.
Beneath the surface of Mars, we will find our new sky.
Is it really possible to construct an entire civilization beneath the surface of Mars? Inside a crater, digging deeper than ever before and turning Martian dust into bricks, like an ant's nest. How big will this underground city be? And where will the materials to build it come from? How will the crater be covered to protect the inhabitants? And what will it feel like to live in this city that is in a hole in the ground? But why is this city being built underground inside a crater? Because beneath the surface of Mars, there is protection from the growing storms of radiation that rain down on the surface every day. The underground city, Valis Arcadia, will rise by the next mass migration, when Earth and Mars are at their closest, and another 20,000 robots and 10,000 human passengers land on the red planet. Working in the harsh Martian environment of dust storms and extreme temperature changes, the digging robots are creating a solid ground for the foundations laid out to the city's specifications. This is Phase 1, the excavation and foundation work. Stations have been built at the top and bottom of the crater, with cable carts and a conveyor. They move materials and machinery in and out of the crater and lift the dirt out. This cable car system will later be replaced with a maglev inclined train line to ferry the population in and out of the city. This phase of the city project, the excavation and foundation work, takes 3 years, with continuous round-the-clock operations by the autonomous machines. Regolith robots convert Martian soil and a plant-based binder into the ExoPave Martian concrete. A nozzle and injection system print layers of this concrete, building up the foundations. It is also used on the sloping sides of the crater. Metal beams, piles, and rods are driven deep into the crater to anchor the walls firmly and stabilize the structure, preventing collapses and landslides, especially during Marsquakes. Looking down into the crater, leveling lasers cover the surface. Small, agile drones maneuver around the construction site, inspecting the integrity of the foundation structure and weaving in reinforcement materials, forming the shell of the city. Part of the foundations include pads for roof columns. The foundation phase is coming to an end, but the digging robots do not stop. They start digging into the sides of the crater, going off on their own journeys. They are forming tunnels, connecting the crater city to the rocket landing pads, lava tubes, ice mines, and even other craters, creating an even larger underground civilization network. This crater was chosen for the city because it is close to rich resources. It is near large subsurface ice water and mineral deposits. It is just like how settlers on Earth built their early colonies near rivers. When the crater was chosen, diggers' scout drones bore narrow holes deep down into the crater. They traveled down these holes, looking for signs of ancient, frozen bacteria. Moving into an existing crater is much easier than digging space for an entire city from scratch. The lack of active plate tectonics on Mars means that surface features such as craters are not as readily erased over geological timescales as they are on Earth. The crater is a small one, about 2,985 feet, 910 meters in diameter, creating an area within the walls of about 0.25 square miles, 0.64 square kilometers, and it is 656 feet, 200 meters deep. Martian soil has a high thermal inertia, meaning it can absorb heat during the day and release it slowly. So underground, the temperature is more stable, unlike on the surface, where there are extreme temperature variations, from 20 Celsius and 68 Fahrenheit during the day to negative 125 and negative 195 at night. Habitats on the surface need substantial energy for heating during the face-freezing sub-zero nights. The foundation phase has finished. But out near the edge of the crater, a small section is still being excavated. The robots dig even deeper than the rest of the city. This is for a different set of facilities that will be hidden away from the inhabitants. The next stage is building the city's structural framework. Phase 2. The pit is filled with swarms of welding robots, throwing up sparks around the crater. This next phase takes 6 years. The city is being built 8 stories high, with multi-story open areas, courtyards, and even a small biodome with a small lake. It will house the 52,000 plus humans and over 120,000 robot workers. The Mars colony is a high-level robot integration civilization with a 2-to-1 robot-to-human ratio. The robots play a central role in construction, mining, maintenance, healthcare, and domestic chores.
Wow.
And they only need less than 10 square feet, 1 square meter, for storage space, while humans need 2,152 square feet, 200 square meters. Humans need a lot to survive. This is why the city is being built underground, because on the surface there is killer radiation, toxic dust storms, and the meteorites. Mars lacks a protective magnetic field and has a thin atmosphere, offering minimal protection against cosmic rays and solar radiation. Solar radiation is the visible light and charged particles that come from the sun. It can penetrate biological tissues and cause damage to DNA and cellular structures, just like a sunburn, but on a cellular level, harming humans and life from the inside out. Or like how Bruce Banner's gamma radiation turned him into the Hulk. Solar radiation comes from one direction, our sun, while galactic cosmic radiation, with higher energy levels, comes from all directions, from the stars seen in the night sky and black holes. Exposure to high levels of radiation on the surface can lead to the degradation of the central nervous system, reduced motor function, changes in behavior, damaged eyesight and blindness, damage to heart and blood vessels, fertility issues, harmful development of a fetus, skin damage, and accelerated aging. Underground habitats provide shielding from this radiation. On the surface, where the colony is now living, habitats have extra thick shells, 3D printed using the Martian soil. Other ways of shielding from radiation include building habitats with water tanks and water walls that surround the living areas. But even the dirt is toxic for humans and needs to be cleaned with water in a bioreactor to remove the harmful perchlorates. And the gravity also hurts the fragile humans. The lower gravity means that humans use to suffer from bone density loss, which is now being cured through bioengineering and gene therapy. Living in the enclosed crater city, the climate will be controlled and the atmosphere geoengineered to be breathable. A big challenge in this stage of construction is building the roof over the crater. The huge crater opening needs to be closed to provide more protection from the radiation, but a small opening is left in the center of the roof, covered with a composite glass to filter out the radiation and to bring natural light down, spreading out across the different levels. The roof also protects the city from meteorites, which is the reason why there are so many more craters on Mars. The glass opening in the roof will have a deployable, retractable shield to completely enclose the city during the months-long dust storms and during major solar flares. While solar radiation happens every day, a solar flare is a sudden explosion on the sun that shoots out a burst of light and energy into space, like a volcano eruption. These solar tsunamis can take out electrical power grids, satellites, GPS systems, and radio communications. It takes 13 minutes for the first wave, the electromagnetic radiation, to reach Mars. The second wave, the charged particles, can take hours or days to reach the planet. Solar flares are classified as A, B, C, M, or X, with A being the weakest and X the strongest, with the potential to unleash a solar superstorm. The roof structure is supported by a framework designed to withstand Mars's lower gravity. Below the roof construction, the 8 levels of the city township are being built. This city, in a hole in the ground, will not be dirty, nasty, or dark. It will be a nice hobbit city, which means comfort. The rooms will have polished wooden furniture and wood paneling crafted from lab-grown wood fibers and plywood made from plant bioglues. The rooms will be carpeted and have wardrobes, for the colony on Mars harvests farmed plants, cotton, and even basalt rock, using the fibers that can be spun and woven into clothing and fabrics for construction. In the center of the city, peering through the opening in the roof, looking through the thin atmosphere of Mars, a telescope observatory will be built. And once a week, the city's lights will dim, softening their glow to show a grand display of live images from the deep night sky. The biosphere, home to a small lake, shall be known as Rama. and in this place, the waters drift slowly, owing to the lower gravity. Plants will rise up inside the city walls, towering over the residents, bearing food to feed the city folk, and an office will be unveiled displaying the title, the Institute of Planetary Terraforming. Upon its completion, the city will stand as the largest example, a masterpiece of para-terraforming. This is the art and craft of reshaping and terraforming a single location, not an entire planet. This esteemed institution will work to green other small parcels of Mars. While dwelling beneath the surface might seem odd for one's spirits and psychological health, these subterranean homes will provide a sanctuary, a controlled environment free from the unforgiving conditions of the Martian surface. While the city settlement is being built to feel homely, more importantly, it must protect the life within the walls. Everything is airtight, and airlocks divide the city into very small, closable sections. Because Mars's atmosphere is too thin to breathe, the city will be pressurized, just like an airtight airplane that actively pumps air into the cabin. The airplane compresses outside air using the engines and then introduces it into the cabin, enabling passengers to breathe normally. Habitats on or under Mars are just like an airplane flying at high altitudes on Earth, where the air outside is too thin to breathe. Pressurizing a habitat means adding air and gases into an airtight container or structure until it reaches a level suitable for human habitation. But all of the gas and air is pushing outwards, like a balloon. This means that the structure needs to be strong, requiring materials that make sure the seals and joints can withstand the pressure differential without leaking. This means using metals, rigid composites, and other durable materials. And all of these materials are locally made on Mars. This is what made the plans for building the underground city possible. Over the years, the colony has become advanced enough to make the structural materials needed to construct the underground city. Along with making the exopave, the Martian concrete, the colony also has facilities to forge iron and steel. The Martian rock, rich in iron oxide that gives Mars its red color, is processed to extract iron. The iron is then combined with carbon from the Martian atmosphere to produce steel. The metal facilities are away from the colony, with furnaces operating solely by robotic workers. The steel is used to manufacture the city's structural components, tools, and machinery. Aluminium and titanium are also extracted and are used in the construction, as well as manufacturing vehicles and aerospace components. And fiberglass made from Martian sand, which is primarily silicon dioxide, is used in constructing pipelines that transport water, air, and fuel, and is also used to reinforce the Martian concrete. The silica in the Martian dirt is also processed to make glass and used to create aerogels for habitat and surface vehicle insulation. And plastics that are turned into flexible materials for suits and habitats and for electronic components are made from the carbon dioxide in the atmosphere that is converted into methane. Phase 3. Next comes the construction of the city's essential infrastructure. This stage takes 3 years. This is when the robots begin building the parts that allow the humans to live underground, such as the water and air processing and distribution plants, the waste recycling systems, the vertical farming towers, and communication networks. Robots are laying down pipes and cables connecting all of these different parts, and the transportation network is being developed inside the city. There will be emergency shelter zones, reinforced areas designed to provide refuge during extreme solar flares or other emergencies such as quakes, equipped with independent life support systems. And the beating heart that powers the city will be an array of fusion reactors, fueled by the hydrogen extracted from the Martian ice water. The city is officially named Valis Arcadia, inspired by Valles Marineris, the canyon system on Mars, and the mythological region Arcadia, symbolizing an idyllic refuge of Martian wilderness. When the construction of the city is finished, it will mark a new level of advancement for the Mars colony, which is already a self-sustaining civilization today, but is still in need of advanced electronics from Earth for making robotics and AI. And in some ways, the Martian colony is already ahead of Earth. The colony boasts a more advanced medical development pace, specializing in genetic and bioengineering, with bio-3D printers that print tissues, eyeball corneas, and bioprinted prosthetic limbs, with ongoing experiments in printing organs, and work continues in genetically engineering humans to be immune from the effects of the surface radiation. The colony is making their own pharmaceuticals, using the carbon, oxygen, hydrogen, sulfur, and nitrogen that they harvest from the planet. Nitrogen is also used for food preservation, dyes, fertilizers, and explosives for construction purposes. The silicon extracted from the Martian rock is also used to make photovoltaic cells for solar panels, powering the research outposts that are located far away from the main colony. Algae and bacteria grown in bioreactors are used in the production of bioplastics for disposable items and packaging. Martian soil is heated to high temperatures to produce various ceramic materials used in pottery, insulating components, and protective tiles. And the colony extracts precious metal treasures such as gold and platinum that are used in electronics and scientific instruments. The construction now enters Phase 4, breathing life into the city. At night, the dwellers on the surface see a glow of light coming through the roof as the artificial lighting arrays are powered up. During the day, the interior lighting mimics natural sunlight, promoting plant growth and supporting human circadian rhythms. The environmental control AI is turned on. This is the brain of the city, working with robotic assistants to maintain the life support systems, monitoring levels of oxygen, carbon dioxide, and pollutants, and adjusting conditions as needed for optimal human health. Fleets of robots begin spreading out inside the city, like bacteria in a petri dish. They live in the walls, under the floors, and up in the ceilings. The city is now a closed-loop ecosystem, fully pressurized with recycling air and water. It begins to breathe. Elevators and spiral escalators across the city connect each of the 8 levels, and for longer journeys, dwellers can enjoy the smooth rides of the magnetic levitation, small-scale rail lines, which benefit from the lower gravity on Mars, moving people and goods throughout the city. And when people need to go up to the surface, they can take the high-capacity cargo and passenger inclined elevator rail line, offering a scenic route to the surface. The pressurized cabins stop at an airlock station